Welcome to the HPC Best Practices webinar series. The series is brought to you by the IDEAS Productivity Project, which is part of the exascale computing project of the United States Department of Energy. I'm Osni Marquez from Lawrence Berkeley Lab. I'll be the host for today's webinar, the OpenSSF Best Practices Badge Program, and the webinar presented by Ross Bartlett from Sandia National Laboratories. Ross earned his PhD in chemical engineering from Carnegie Mellon, where he did research on numerical approaches for solving large-scale constraint optimization problems in chemical processes engineering. Then he went to Oak Ridge and Sandia, where he continued to work on doing research and development in constraint optimization, sensitivity methods, and large-scale numerical software design integration for computational science and engineering, CS&E. Ross currently focuses on software engineering challenges in CS&E, as well as development of build, test, and integration software and process for CS&E. We have issued about 100 tickets for today's webinar. Not everybody shows up, but we have muted all attendees upon entry. But, at least I tried here. So we'll be receiving questions through the Zoom chat and also the Google Doc, whose address I'll paste in the chat momentarily. We have asked Ross to add breaks during his presentation so he can respond to the questions that come in. With that, Ross, I'll stop my sharing and take over.
All right, thank you, Osni. All right, so can everybody see okay?
Yes.
Excellent. Right, so I'm going to talk about the OpenSSF Best Practices Badge Program. So this is something that I came across about 2 years ago, and I was just really impressed by the scope and the breadth of the program. And I thought it was a really useful program, and with a lot of very interesting features and benefits that I thought could really benefit our community. So I want to point out that I wrote an article on this on the Better Scientific Software site about a year ago, and I recently updated it with some more recent statistics about the site. And a lot of what I'm going to talk about today in this presentation is also discussed in that article on BSSW.io. So one thing I want to address right up front here is that one of the S's in OpenSSF stands for security, the Open Source Security Foundation. And I want to talk about issues of security up front here and kind of put them in context within these best practices. So there's been increased interest and concern about software security in general for the last several years. And in the last couple of years, we had this executive order on improving the nation's cybersecurity that came out, Order 14028 from the White House. And so a few key quotes from that executive order. Incremental improvements will not give us the security we need. The federal government must bring to bear the full scope of its authorities and resources to protect and secure its computer systems. And all federal information systems should meet or exceed the standards and requirements for cybersecurity that are set forth in this order. There's debate at different institutions about what constitutes, I guess, a federal information system. But I know that we're being impacted at my organization. We're feeling the impacts of this executive order and some increased emphasis on trying to improve our security in different ways. So this is one of the drivers for this. So just in general, if you do a Google search or a web search on open source security vulnerabilities or issues, you'll find a whole bunch of articles. Here's just a sampling of some that I found when I searched just recently. For example, one of these articles is about the Heartbleed bug in this OpenSSL package, very critical package for our security infrastructure. And so what's interesting about that is that the OpenSSL Heartbleed bug was exposed and it was fixed in the source way back in 2014. And they're still writing articles about it 8 years later for the impact that that has. So a natural question to ask, and everyone's going to ask it, and frankly, I asked this myself recently, is how does software security impact computational science and engineering and the high-performance computing communities? Well, a couple things. Well, first, just the general and cautious usage of software systems can create problems for our institutions. I know that we've all, in all our institutions, recently we've had, yearly or more frequent cybersecurity trainings to avoid, clicking on links and suspicious emails and text messages and so forth. And when I was at Oak Ridge, they had a major security issue years ago that cost, quite a while to recover from and so forth. Institutions are having problems all the time. So, the software installs that you do, for example, can create vulnerabilities in our systems and our customer systems through the software that we're installing, or even how they're installed. And even some of our, CS&E, HPC software itself may actually get run in environments and sort of, user-facing environments that could open up security vulnerabilities for those applications, depending upon, how our software is written and what vulnerabilities it has. And then the increasing usage of workflows and pipelines and containers for DevOps for our CS&E HPC projects brings with them a lot of different possible security vulnerabilities. So with that, let me just define the Open Source Security Foundation. Hold up. Make this thing go away. Sorry, this irritating thing is not going away from my my slide here. Okay, here we go. Right, so the OpenSSF stands for the Open Source Security Foundation. This is a foundation under the Linux Foundation. It's a cross-industry organization. It brings together the industry's open source security initiatives and individuals, and their vision is a future where participants in open source software ecosystem use and share high-quality software, where security is handled proactively and by default as a matter of course. And the foundation is supported primarily by its premier members that provide the funding for it. And it basically includes all the major tech companies in the industry. Some of the more major ones that we all know about are shown here. So is there any questions up to this point?
Not yet, Russ.
Excellent. Okay. Now let me provide an overview of this best practices badge program and why I think it's so useful. So this is a set of best practices that have been curated by the open source community for projects that are actually using them. And they have very specific actionable criteria and require supporting evidence. This is different from a lot of other best practices efforts that I've seen that are kind of high level. It's not clear what to actually do to satisfy these things, where these are very specific. And they give you very, very specific advice, what's needed to satisfy them and where to look for more information. And I'll show some examples of that. Now, what's particularly unique about this set of best practices is that there's a very strong focus on software security, which partially addresses this White House executive order, for example. And this applies to, US government, national laboratory, and so forth. But I want to, so while this comes from the OpenSSF Foundation, and it has a really strong security focus, I want to point out that most of these practices are applicable to all software, and not just to security critical software. And for those practices that are specific for security critical software, a lot of them just don't apply to the kind of software that we develop day in and day out. So I don't want people to write off these best practices just because there's a security focus to it. But I will talk about some of the implications of this set of best practices related to security, which are somewhat challenging. So one of the, another unique feature of this program is that there's this very featureful, quote, badge app site that enhances the display of each practice, expanded descriptions of the practices, and it provides a way for projects to create entries for their project to check off which practices that they follow and how they address them and where to find out more information. So once a project has created an entry on the badge app site, then they can basically display that badge or what progress they've made to a badge on their own project's hosting site. And with links back to the OpenSSF project page for that project. So what I found from working with this is that I think this set of practices is a pretty effective learning tool. And I'll talk more about that later. It also provides a roadmap for continual improvement in a project as it incrementally adopts more practices and improves its scores in different areas. Another benefit is that it provides a standard index into parts of a project and how it handles different kinds of processes. And finally, I think actually the way this is implemented and the way it's documented, I think this might actually provide a pretty attractive sort of template to kind of fork this, badge app site, and you could modify it and customize it for, less than open source projects and some of our internal programs, for example. Get rid of this bar here. Let's see. Okay. All right. So let me provide an overview of the best practices program. Okay. So the best practices are broken down and organized in several different ways. First, practices can either be required or optional, and there's two levels of optional. So the ones that are required are listed as must, with the word must in it, although many of those can be marked as not applicable if they don't apply to your project or your kind of software. And then there's practices that are listed as should or suggested. And should practices, if you don't follow them, you have to provide a rationale for why you're not doing it. Now, the practices are broken down into three different badge levels. There's a passing level, there's a silver level, and a gold level. And each level adds additional practices that are required or suggested. And within those three different badge levels, the practices are broken down into 6 different categories, of which security is only one of those categories. And then each category is broken down into one or more subcategories. So this is what the practices look like, the way they're displayed. So it's showing the practices for the for the level of the badge. In this case, the passing level. This is the basic category, and then the basic project website subcategory. For example, the first one there is the project website must provide information how to obtain and provide feedback, and so forth. And each of these practices has a unique short identifier name for the practice. So it's non-ambiguous, and that short identifier is also a link onto the website that basically defines the practice. So you can provide web links to these things by just putting in that short link name. So here's a sampling of some of the practices at the passing level, just so you can see sort of what these look like. So again, at the basic project level, the project has to describe what the software does, what problem does it solve. The project website must provide information on how to obtain and provide feedback. I already mentioned that one. Information on how to contribute must be provided. And then it's optional to provide criteria for how, for what contributions will be accepted, essentially. And some of these have URLs that are required to point to more detailed information or how that practice is satisfied. So over on change control, the project has to use version control, and it's got to be in a public, at least read-only repository. The project source repository has got to track what changes are made, who made the changes, and why they were made. And it's got to enable collaborative review to allow for review of interim versions of the software, in between releases, and not just, doing reviews of final releases. And it's suggested to use a distributed version control software like Git, but these days pretty much everybody uses Git, I think. So more examples of sample practices at the basic passing level. So on the reporting category and bug reporting process, the project has got to provide a process by which users can submit bug reports. That's the report process. The project should use an issue tracking system, but doesn't have to. The project must acknowledge major bugs that are reported within the last 2 to 12 months inclusive. But the response need not include a fix. That's interesting. So I guess your software is allowed to have bugs and SOE passing. The project should respond to the majority of enhancement requests within the last 2 to 12 months. It actually doesn't require you to respond to all enhancement requests, just at the passing level. And your project must provide a publicly available archive to search prior bug reports and responses. On the vulnerability reporting process, your project has to provide a sort of a secure way to support vulnerabilities in your software somehow. So over here under quality, under working build system. So if your software has to be built, it's got to provide a way to automatically build it from source. You can't just be able to type in compile commands. And this one is an example of a practice that can be marked as not applicable, because all software doesn't have a build process, like Python, for example, is just the interpreter. The project must have at least one automated test suite that's publicly available as open source software. And new functionality, and there must be a general policy that as new functionality is added, that functionality gets tested. Well, this kind of squishy term here that the tests for that functionality should be added to the automated test suite. It doesn't say that it has to be, which is kind of interesting. Okay, so last, a third set of samples that you'll see at the passing level on security. And I'll talk more about these two here. Secure software development. These are quite different. The project must have at least one primary developer that knows how to design secure software. And the project, one of the primary developers has to know the common kinds of security vulnerabilities. I'll talk more about these in detail later and why these are so interesting. Over on the analysis side, static analysis. So, to reach a passing level, your project has to use a static analysis tool beyond just the basic compiler. Unless the language that you're using doesn't have any tools available for it, so you can mark it as not applicable and describe why. It's suggested that you use at least one static analysis tool that can look for common vulnerabilities in the language that you're using. And of course, some languages just doesn't have a tool for that, so you can mark that as not applicable if you're one of those languages for your project. But you've got to fix all the medium and high security, or medium and high severity exploitable vulnerabilities that are discovered through the tool in a timely way. And it's suggested that you run this tool, very frequently. So I just want to point out, that most of these practices are applicable to almost all software, and not just security critical software. So some of the criteria for the statistics themselves broken down into different categories, and the number of must, should, and suggested shown here. Number of not applicable, those that require a URL, and so forth. And by the way, if a practice requires a URL, if you don't put it in, you'll get an error because it actually searches to make sure that it can access that URL. So just some notes and observations about this. So all these practices that are listed here, the numbers are not all unique. Some of the practices are relisted at higher levels, going from suggested to should, or should to required. For example, at the SOVA level, the bus level, or the bus factor practice, which says that your project has to have more than one primary developer that can make changes and can sustain the project. That's just a should practice at the SOVA level. It's not even mentioned at the basic passing level. It's relisted at the gold level as a must. To be a gold level project, you have to have a bus factor of 2 or more. But I want to emphasize here, and I'll emphasize that more later, is that most of these practices are not specific to security. And even the ones that are specific to security can be marked as not applicable, which is the case for most CS&E software that's not dealing with things like encryption and authentication and so forth and other things. All right, so any questions about the practices?
Hey, Ross.
Yes.
Yes, we have some questions here. So let me go, let's see here. Do most exascale projects provide information on how to contribute?
Do most exascale computing projects? I don't know. That's a good question.
Okay. And next one, can you clarify how should differs from suggested?
Yeah, so basically, over here. Yeah, so a should is something that if you don't do it, you have to give a strong argument why you didn't do it. So you have to provide a justification. You got to type in why your project didn't follow it. If it's suggested, a lot of times you can just hit not met without requiring a justification. So the idea was that your project would be viewed, the practices that are should and not met would be reviewed by people with greater scrutiny than those that are just suggested. So does that answer your question? Yes, no?
Yes.
Okay. Right. Any other questions?
All good.
Okay. All right, now let's talk about the OpenSSF best practices badge app site, which I think is probably the most useful and unique part of this program. So this is the URL to the badge app site. It's under this domain core infrastructure initiative. So you actually will see on this site both OpenSSF best practices and also core initiative. That was a prior initiative where this program was started under, and then it was, and then that program went away and it was superseded with the OpenSSF Foundation. Anyway, so as of a couple of weeks ago, this site had 5,800 registered projects on there at all levels. And the first project they put in was the badge app. And that one is listed as gold, I guess, partially just to demonstrate how you're supposed to use this site and how you're supposed to fill in the fields. And also just to show that, they're following that, that they're eating their own dog food, essentially, right? Essentially, okay. And some of the projects that have earned badges are shown over here. They're icons like the Linux kernel, other big ones, GitLab, things you might be familiar with, OpenSSL that we mentioned earlier, curl, Node.js, and so forth. So with this badge status, you can select several different things. So this is, for example, all the gold level projects. So there's, was currently 19 projects as of last week. The badge app, of course, is one of them. Another one, which is very comforting, is the Linux kernel itself is listed as gold. Another, very critical project, curl, for doing communication and transfer of files. So yeah, you can search different levels of projects and see which ones satisfy different levels of criteria. So looking at the growth of the best practices site. So this is showing a chart of the number of registered projects on that site going back to 2016 when it was first created. And as you see, it's been growing very steadily over the last 6 years or 7 years, I guess. And actually, it's even accelerated recently here in the last year or so, which is interesting. So this shows that this is a well-accepted and adopted badge program and site. And just one thing I want to mention here, you'll see that you can actually reduce the number of projects that are actually added. So if you create a project and put it on there, and if for some reason you need to take that thing down, you don't like something about this best practices program, or it's not appropriate for your project or whatever, you can remove your project and it'll get wiped off the site essentially. So that's how you can see this thing actually drop down. Now let's look at some of the badge level and adoption statistics. So, of the 5,800 projects that are registered as of the 5th of June, 70% of those had achieved a passing level, but only about 0.8% or 8 out of 1,000 achieved a silver level badge, and then only 0.3% or 3 out of 1,000 achieved the gold level badge. And I will have, just on a side note, if you look over this, you'll see that there are several projects that are listed multiple times, and only one of those is sort of the official one. So that's kind of interesting. Someone will post something for a project that's not the official entry, and I guess they'll gripe about the project or something. But yeah, so all 1,500 of those of those entries registered are not like, fully legitimate entries for those projects. So that skews the statistics a little bit. I don't know the exact number because that would be hard to determine exactly, but I just wanted to point that out. So this chart shows the growth and number of projects that are making progress or have achieved a passing level. So I should note that when you see the percentages, if you're at 100%, that means that you have satisfied all the criteria for the passing level badge. And then when you go above 100%, it means that you've achieved passing level and you're going towards silver or going toward gold. So if you're in the 100s, it means you're passing and you're on your way to silver. If you're in the 200s, it means you've received a silver and you're on your way to a gold. And a 300 is the best you can get. So that's just the gold level. So this is what the best practices badge app site for the project page looks like. So to try this out, I took one of my projects and I created an entry for it a couple of years ago. And I spent quite a bit of time on this. So this is what it looks like for a project. This is displaying the passing level right here. And this shows you the 6 different categories and the number of criteria in here that you marked. Now, I should note that in order to receive, credit for a practice, it either has to be a must practice that you have met, or that has been marked not applicable if it's not applicable, or if it's should or suggested, you had to at least respond to it, even if it's to say that you've not met it, but you have to acknowledge all the practices in all of these categories in some way. And I'll note that I do not have a 100% passing badge because of one of the security level criteria that I'll talk more about later in this presentation. But this is what the site looks like. Now, this is what it looks like when you are, responding to one of the criteria. So this is the release notes criteria. Release_notes. It says that so at the passing level, your project must, for each release, provide release notes that are human readable summary of the major changes. And this cannot be just a get log from the last time you did a release. And you're required to provide a URL to describe that. So in the Trivets project, I have a change log file that I've been updating according to what are suggested best practices for a change log. But actually, there are a lot of projects, even in ECP, that don't produce release notes. Okay, so once your project has created an entry in the badge app, then you can display that badge on your various websites for your project. So this is inside the README file on the GitHub page for the Trivets project. And it shows that I'm achieving 99% on my way to a best practices badge. Now, if you click the edit and look at it, this is in restructured text. There's also examples that you can find for this in Markdown for how to do this. But it provides 2 different links. One is the link that actually generates the badge for you, that creates that image, essentially. And the other is a target. And again, so I mentioned the alternate text, which is the pop-up here. A lot of places you'll see that it says it's the CII best practices. That was the old name for it, and it is now called the OpenSSF best practices. So it's easy to display this badge on your various project websites. All right, so let me stop for a second and ask if there's any questions about this.
Yes, Ross, there is one here. So does the OpenSSF badge program install any software on the registrant system for verification purposes? Or does the registrant just have to answer some questions on the web?
It's all questions on the web. There's no software you have to download, but you do have to provide links to evidence for a lot of the criteria. So again, this is for open source software. So the idea is that you would provide all this information would be open on the open web that the badge app site can get to. But yeah, there's nothing that you have to download. It's all on the website.
Okay, continue, please.
Okay. So let me talk about some of the other benefits of the OpenSSF Best Practices Badge Program. So one benefit that I found, at least for myself, is that I think this is a pretty effective learning tool. So when you go to the full set of practices, so there's this page called criteria under the main site, where it lists out the criteria for different levels or all the levels, and you can tell it to list additional information. And it gives you a lot of information about each of these practices and the motivation for them and how you can satisfy them, what the issues are, and so forth. And then within the badge app itself on your project page, each practice has a little button called Show Details that can go into greater detail about that practice. So you can learn about it and what it takes to satisfy it. And then there's like a Show All Details button at the top of the page of your project page. Now, reading through all 129 of these best practices in detail and clicking on some of the links can easily take more than half a day, or might take much longer depending upon the level of your familiarity with each of these areas. So, I've been looking at, I've been reading books on software engineering for many years, best practices, articles, and so forth. So I was familiar with a lot of these areas, but I wasn't always, I was surprised what was considered to be the current state of the art for the best practice for some of those areas. So I actually learned a lot from going through this. And I think it took me probably more than half a day to go through all practices up through the gold level just to see what was involved with them. And I expect some people that are newer to this might spend quite a bit more time than that, just going through this material. So here's an example of what this additional information looks like. So in the area of free open source licenses, it says that, the software produced for the project has to be released under a free open source license. And this is in the basic passing level. So if you look at the details, it basically describes the definition of open source software, the definition of open source licenses. It gives some common licenses that are used for open source software. And then it states that, you have to select a license that is approved by the Open Source Initiative, by the Free Software Foundation, and it's got to be acceptable by, the Debian and the Fedora Linux distributions. Because I think all of us would like to potentially see our open source software being able to be a candidate to be in one of the major Linux distributions, I think, because that makes it just available to everybody pretty easily. And then, some of these have a rationale where they describe why this practice exists and why it's important. And sometimes there's links that come off of this. I've been looking into open source licenses for a long time, going back to graduate school. So this is an area I'm pretty familiar with. But if you're not familiar with open source licenses, you could spend, many hours just on this one topic, looking through these links and seeing what's involved here and how it impacts your software. It can take, days potentially if you have some particularly, tricky issues with your software and so forth. Anyway. All right, so this is what it looks like if you click the Show Details link inside of your projects or any of the projects. Well, actually, this is only available in the edit mode, so it would be for your project when you're editing your project. You can either click Show Details or Hide Details if you're showing the details. So this is the same entry for the FLOSS license, and it goes into the to the details, but it doesn't give the rationale here. The rationale is only given on that other criteria page. Okay, so another benefit is that you can use the OpenSSF best practices site and your project on that site as a way for helping you to work on continuous improvement. So for example, on the project page on the badge app for your project, you can basically show all the unmet criteria. And you do that by clicking on the expand panels and hiding the met criteria. And what that'll do is that will show you all the criteria that you marked as unmet or didn't respond to at all. But it will hide all the ones that you've met or marked as not applicable. And you can do it based on the level that you're interested in. So the badge app site will also send out periodic emails about the status of your project. And I'll show an example of that. All right, so this is what it looks like, for example, for the Triple Core project. When I clicked on the expand panels and hide the met and the not applicable. So under change control, I met the unique version numbering as unmet in the basic level. Instead, it is suggested that the semantic versioning standard or the counter versioning standard is used. And I listed that, for Tribits, it doesn't put out official releases, it just does, almost continuous integration with its updates. So it's actually not required at the passing level to put out, numbered releases or to follow any of these standards. It's just suggested. But in that, but you should know what's considered best practice, even if your project doesn't follow it. And I think that this is actually pretty helpful, because I think very few projects actually follow the semantic versioning standard. Okay, so here's an example of an unmet criteria. So this is where the Tribits core project fails its passing badge. This is where it gets deducted 1 out of that 16 of security practices. That the project must have at least one developer who knows how to design secure software. And then there's details on exactly what those requirements are. And at this point in time, in good conscience, I cannot click yes for that. And I'll talk more about this particular criteria later. Oh, and as I mentioned earlier, the badge app site will send out periodic emails. This is an email I received back in April, reminding me that I've not yet received a passing badge for my project and where to click on to modify it and how I can look for missing criteria and so forth. It's signed by David Wheeler, who's the lead of this effort. He's also the lead of the working group for the best practices group in the OpenSSF Foundation. Okay, so another benefit of the badge app site is that it actually provides a pretty useful standard index into projects. So the badge app project page, gives a standard list of practices. It makes it easy to find out how a given project addresses, certain types of issues and how to access those. The most basic example is, how does a project handle issue reporting, which is, I know is a required practice for the passing level. So every passing project has to do this. So I can just go to their project page, click on it, go to here and see how they do it. Now here I'm showing it for the badge app, for the badge app project, project 1. And the click is met, and then they give a URL, and the URL is required. And in that case, you can either report issues through GitHub, or you can use a mail list to report issues. So, most projects do a pretty good job of describing how to report issues, but there's more obscure things. Like, for example, I was really curious about how this badge app site was actually implemented and whether we could actually potentially clone this thing and use it for some of our internal projects, because it's just open source software. Well, I knew that the best practices has, a documentation architecture practice, and it's actually required at the silver level. So I went there, found that practice, and found the link to the implementation documentation for their internal implementation. And from that, I was able to read about how they did it. So it's actually pretty interesting. You can go to any of these projects that are on there. If you're curious about how that project does something, you can go and look at it. And that's actually a pretty interesting way to learn how different projects address these different kinds of practices and criteria. And otherwise, this kind of standard index for projects just doesn't exist as far as I know. I know the ECP, and they've been trying to do this with the scientific, with the software technologies project, but this is a much more comprehensive version of that, I would say. All right, so any questions about that?
Yes, there is one, Ross. Who decides what is a best practice?
That's a great question. So in this case, this is curated from a community of people that are associated initially with the core infrastructure initiative of the Linux Foundation. And it's pulled together by, sort of, I guess, the exemplar open source projects that are following these practices, and I guess can make arguments for their value. So it's from the community of people that that curated those practices, and you can see lots of discussion about this if you want to. If you go to their GitHub site, you'll see that people have asked questions about these issues. Early on there was some refinement. There's not much refinement lately because I don't think that they want to change them and kind of pull the rug out of different projects. Certainly they don't want to change the passing level, let's say, for example. But yeah, that's a valid question, right? And you want to make it clear that every practice is not applicable to every kind of software project. And that's why a lot of the practices are listed as either suggested or should, or even just not applicable. So does that answer your question, Greg?
Yeah, sorry, Ross. Yeah, I think that mostly does. It just, is there like is it just done by community consensus then? Is that to sum it up? Or is there like
I think that's correct. And
Okay.
you know, but part of it could simply be that these are the practices that they decided on if they're going to give you a badge, right? So by getting a passing badge in this program, what you're saying is that you have satisfied all the criteria that that particular project or program designated was required, right, in order to be able to be considered passing. So in that sense, they get to define what best practice means because it's their badge.
Yeah, that makes sense.
And I've seen, if you do web searches, you'll see that there are certain projects and programs that will put out press releases and blog articles bragging that they have achieved a passing badge in the OpenSSF program. So just go on Google and search for OpenSSF or CII best practices, achieving a badge or whatever, and then you'll see several articles that have been written for projects that are bragging that they've received this badge. Okay, so let's move on to the security practices. So much time do we have left here? Let's see here. Another 10 minutes or so. Okay. Right, so let's talk about some of the security practices in a little bit more detail here, where things get interesting. So what's interesting here is that the OpenSSL project, they actually created two different entries in here. They created 87, which marks sort of where the OpenSSL project was before the Heartbleed bug. And then they have a current project, OpenSSL, for what they have done after the Heartbleed bug. So a couple things to know about this. So before the Heartbleed, first I should mention, Heartbleed bug was identified and fixed back in 2014. This site itself didn't even come into existence until 2016. So these are all done after the fact, obviously. But yeah, I mean, so the Heartbleed bug, OpenSSL only achieved a 63% to a passing badge. And again, a lot of the practices that you read there are pretty common sense stuff, or things that you've read about or seen people do for at least a couple decades, probably. So a lot of these things are not, shouldn't be shocks or surprises to most people. And then I guess today, it's interesting that OpenSSL only achieves a passing badge. They haven't gotten past that. I mean, they've only gotten 5% past that to achieve a silver level. So I guess they just wanted to note that they achieved it and then moved on. Okay, so let's focus on the security practices themselves. So 16 of the 67 passing level practices are specifically for security under the security category, but 9 of those 16 you can mark as not applicable. And for example, for my Triple Score project, I mean, almost all of those were not applicable because a lot of those have to do with cryptography and authentication and things that most software doesn't actually deal with, really just security critical software. So 18 of the additional 55 server level practices are in the area of software security, but 11 of those can be marked as not applicable. And then 5 of the additional 23 of the gold level are security, and 3 of those 5 can be marked as not applicable. So, until recently, software security was barely even mentioned in most software engineering books. So a classic example of this is sort of probably my favorite book on software engineering is Code Complete Second Edition, published back in 2014. That's a big book. It's 800 plus pages. And in that entire book, there's exactly one paragraph that is devoted to the area of software security. So in section 3.5 under architecture prerequisite, it says that the architecture should describe the approach to design level and code level security. If a threat model has not been previously built, it should be built at architecture time. Coding guidelines should be developed with security implications in mind. including approaches for handling buffers, rules for handling untrusted data, encryption, level of detail contained in error messages, protected secret data that's in memory, and other issues. I mean, he points out a lot of things here, but it's, you know, but it's like, actually, is that even just one sentence? That's one sentence, isn't it? It's not even a paragraph. No, actually, I'm sorry, it's 2 sentences. There's a period there. But more recently, so I just got a copy of the Pragmatic Programmer, which is, you know, between, you know, Code Complete and the Pragmatic Programmer. That's on, you know, one of the two is on everyone's list of most recommended books to read on software engineering and software development. So in the 20th anniversary version, which came out in 2020, that's a much smaller book, 300 pages. They actually devote 7 pages to the topic of software security under the topic 42, stay safe out there. So one thing to note about this is that, you know, the awareness and visibility of software security is definitely increasing. You can see this in the literature and in terms of the different, you know, programs that are basically pushing on this. And then, of course, there's things like this White House Executive Order 14028 on software security that I mentioned earlier. So in my view, for probably most projects and most people, these two passing level security topics or criteria are the most difficult to satisfy, okay? So the project must have at least one primary developer who knows how to design secure software, and at least one of the project's primary developers must know the common kinds of errors. You know, what do they mean by no secure software? You know, how to design software, you know, or know the kinds of vulnerabilities. And when they know that these are not even practices, these are not things that you have to actually do. These are really just asking the question, do you know what you're doing? And I can't think of any of the other 129 practices that are just asking the question, do you know what you're doing? Like, are you even educated enough to even answer these questions about the later questions about software security? And that's an interesting question, actually. So here is the here's the detail on the, you know, your project has to have one developer that knows secure design. So they go into details here and it says, you know, you got to know the basic 8 critical principles from Scholzer and Schrodinger. And I cut this down a lot. There's way more detail. That's when you know, look at the details for this. You know, there's 8 different areas: economy of mechanism, faults, you know, fail-safe defaults, complete mediation, open design, separation of privilege, least common mechanism, psychological acceptability, limited attack surface, and input validations with allow lists. And it basically says that a primary developer has got to be someone who really knows the code base and can basically be reviewing things. Now, this is where things get a little bit sticky, okay? You know, they say, yeah, you know, there's many books and courses that are available to help understand how to design, you know, secure software. And they give an example of one of these courses, okay? So I looked into this secure software development fundamentals course. It's actually free, but if you want a certificate, you got to pay for it. It's a few $100s. But it looks to be like, you know, like a 3 credit level, college level, 1 semester course. So it's a pretty significant investment to take that course. So more recently, I was looking around the OpenSSF best practices working group site, and they've got this concise guide for developing more secure software. And one of those is, you know, learning about secure software. So they give a couple different examples of, you know, ways that you can learn about secure software. And the lowest overhead one, which is fairly new, is this free OpenSSF course. And that one is 18 hours every 2 years. And that looks to be the least time consuming of all the options that they've given. Yeah, so the question is software security important enough for our projects that we need to have one person on our project devote 18 hours every 2 years to you know, being recertified in this course, so that you can legitimately check yes on that. So I should say that, you know, prior to this, I was not willing to take a college level course on this, but I think I am willing to devote 18 hours just to see what's in this course. And then I'm going to write a blog article and put it on the Better Scientific, or I'll submit it to the Better Scientific Software site and see what I've learned here. So the last one is, well, not the last one, but the other really difficult one is, you know the common kinds of errors. that can exist in the software that you're producing. There's lots of categories, and they mention classic buffer overflow. There's a couple of sites that they mention. So one of the more interesting ones is this CWE SANS Top 25. And then, of course, they mention this, Secure Software Design Fundamentals course to teach you about the security vulnerability areas in more detail. Presumably, if you took that course, you could check, this thing as well. So let's look at the 2022 version of this CWE SANS Top 25. So these are reported. This is some kind of survey that they do or study that they do to look at the top security vulnerabilities that are reported in software. I don't know if this is just open source software, I can't remember. But I picked out, so if you go to that site and look at the table there, I picked out 9 of the 25 that I think definitely relate to a lot of our CS&E HPC software, even just the core computational software that we're writing. So I'll note that 5 of the top 11, out of bounds write, out of bounds read, improper input validation, using after free, pointer reference. These things are incredibly common in all of our CS&E software. Everybody that writes software in C and C++ and Fortran experience these things all the time. And there's a lot of these bugs that are still latent in a lot of our software. It's guaranteed. But what I will note about this is that many of these issues are not just security vulnerabilities, but they're also major causes of software bugs impacting our software correctness that can cause our computational software to give the wrong answer or to crash the simulation. Or just the general robustness of our software. So one thing that I've kind of come to realize is that I think you can draw the conclusion that software correctness and quality and software security are really best friends. That if you're focusing on your core software, if it's not security critical software, if you focus on the things that affect software correctness, like these top 5 right here, you're also making your software a lot more secure. And all of us want to have software that we can trust and rely on, and even if we're not primarily concerned about software security. All right, so in summary, the OpenSSF Best Practices program provides a set of actionable criteria that you could argue that is the open source community's curated best practices. And the best practices badge site helps you to codify these best practices and to list those out and provide fields to fill in how your projects or how projects address each of these best practices and whether they follow them or not. And then once you've got an entry for a project, you can display a badge on the project's hosting sites to show that your project follows those accepted best practices. The badge app site contains features to help your project continue in its process improvement as you are able to meet prior unmet practices and improve on the existing practices that you have. It sends out regular email reminders to help you with that. And for looking at this before, I thought that we could have a project potentially in some of our institutions to actually fork the implementation for the badge app site and then make modifications for some of the practices that were less than open source software that are more particular to some of our larger programs, and that could have a lot of benefit. And just in the end there, I'll just say, these best practices badge program, it elevates security to first level concern for everyone that's developing software. And so the real question that I have that I want to try to answer here is, and a lot of us are going to need to answer for our various projects, is what is the minimum level of sufficient knowledge of developing secure software? And one thing we have to think about, things like this DOE order about software security, there may come a time where there's a certain set of security practices that have to be followed for software, or they won't even be allowed to run on government controlled systems. And there may be a day that comes where that happens. So to the extent that we can be sort of minimally proactive in addressing security, we may be able to avoid some of those problems. And finally, a suggestion I would have, which is a challenge is for people that are here, is go ahead and go up on the Badge App site and create an entry for your project and just see how you do on some of those. What you'll find is that a lot of the things you're not doing that are actually pretty easy to do. And it probably has some value for your project and for your users and stakeholders, so you can actually do them. And then you can sort of confront some of these questions that I've put here in terms of, again, is there somebody on your project that really knows how to design secure software and what that means for the kind of software that you're developing? So with that, we're at the end of our time here, and I'll accept or try to answer any questions or comments that you might have.
Hey, Ross, yes, there is one here. So does the badge get reset every 18 months?
Sorry, what?
Does the badge get reset every 18 months?
I don't think so. Did you see somewhere where it is reset every 18 months?
No, I think it was because you talked about the training, I think.
Oh, the training. Yeah, but I think they're basically going, look, they're not, look, any of those practices can go from being met to unmet. And they're basically, in that particular area, they are going on your own best faith effort and due diligence to have met the criteria for the practice. So I suspect for some projects you probably don't need to be recertified every 2 years. But I think that's something that we have to ask. I mean, a lot of us are not developing security critical applications, so I wouldn't think that I would need to take that again for the kind of projects that I'm working on. I wouldn't think.
Was another question. Are the 2 books that you mentioned the only good ones on software security?
Oh no, those are not even good books on software security. There's many good books that are written on software security. I'm not an expert on software security, obviously. I was just pointing out that those are very popular general books on software engineering, and they're very sparse on software security. That's what I was pointing out. Yeah.
I think we still have a few minutes left here. So the speakers, participants would like to unmute themselves and ask directly to Ross. Further questions? You folks who are still with us can unmute or write in the chat.
Well, Ross, we just had a little discussion about the security issue, and thanks for your answer. I think it's just put on the owner of the repository to update that if they need to. I mean, the other problem was, what if the person who has the security knowledge leaves the project?
Yeah, I think
that goes in that too.
Yeah, I mean, I think those are great questions. But again, I mean, any of the practices could go away, right? I mean, you might have, for example, a static analysis tool running on your project right now, which is required to meet the passing level. But but your process of using that tool might go away at some point. So your project might legitimately not be passing anymore. And I guess what it would say is that if your project says that it's passing everything, means somebody could go and click on your links and they could go to verify that you're not actually following those practices, which means so this is going on, sort of, the honest scout kind of thing, right? Where you basically are being honest about these things, because these things can be checked on, right? You're required to provide evidence and links to URLs for evidence to these things. And if I go to your dashboard and if I don't see any static analysis results, I don't think you're running static analysis. Or if you say you're running dynamic analysis, but I don't see any dynamic analysis showing up on your dashboard, I'm going to question whether or not you're actually running the dynamic analysis, for example.
So I have a question too on how to get started and the hesitancy to have it out there that I'm not, I am or I haven't filled out part of it or whatever.
Well,
And so I
I'll
look
just kind
really
of,
bad.
yeah, yeah, I mean, if you're in the process of getting a badge, I think that's okay. But you should probably, devote half a day to go through it and see what and just see what you've already accepted. Because I think it probably says more for your project that you're making a good faith effort to kind of work on these practices than if there's no entry there at all.
Okay, thank you, Ross. Thank you all for joining us today. I'll just stop the recording.